Okay, so we're back with part two of the video lesson that we started in the last one. Let's take a look at this theorem and then we're going to apply it to solve some problems. This theorem reads that in the same circle or in congruent circles, chords equally distant from the center or centers are congruent, and congruent chords are equally distant from the center of the circle. So let's take a look at part one. So again, if we take a look here, we're given that, let me grab the highlighter actually, OX and OY are both equidistant from the center. And what that means is that segment AB has to be congruent to segment CD. Those two chords have to be congruent. Now, if we look over the next one, we're told that AB is congruent to CD. And what that means is if, again, those two chords are congruent, then they're also going to be equidistant to the center of the circle, which means these two segments here would be congruent. All right, so let's try and apply these ideas. And then after that, so I'm going to go through these. There's three examples we're going to look at, examples 5, 6, and 7. And then you guys are going to try some on your own. So let's take a look here. So here we're told that circle O has segment FL that's equal to 3. So I'll highlight that. So FL right here is equal to 3. GO is equal to 5, and we'll just use this highlighter here. So GO equals 5. And OP is equal to 4. And we want to find segment HJ. This one right here. All right, so what I'm going to do here is I would really like to know the length of OL. Because if OL is equal to 4, that means that GF and HJ have to be equivalent to each other. Now, what we already know here is from the theorems that we studied in the last video, since this segment is perpendicular to the chord, this segment has to equal 3 as well. So FG has to equal 3. Just jot that down over here. Now, what I'm looking at to help us out is this triangle that I just highlighted in green. That is a 3, 4, 5 triangle, which means that OL has to equal, I'm sorry, not 3, OL equals 4 units. Now, what that tells us is that OL and OP are the same length. So OL equals OP. Now, since OL and OP are the same distance from the center, the chords that they intersect are also going to be equal to each other. So HJ is going to be the same length as FG, which we found is, sorry, not FG is not equal to 3, it's equal to 6. FG is equal to 6, so that means that HJ is also equal to 6. Sorry about the confusion there. All right, let's take another example. Example number 6 says sketch circle O with radius of length 17, chord length is chord AB of length 30. How far is the chord from O? So I'm going to draw a circle, or at least attempt to. That's not too bad. All right, and then call that center O, and then draw in a radius of length 17. Now what I'm going to do is I'm going to draw in chord AB, and we're not told exactly where to draw that, so I'm just going to draw it right here so it's intersecting our radius. So that's AB. Now the chord length in this case, we're told, is 30 units. So what we're trying to figure out is the distance from O to the chord. Okay, now again, based on a theorem that we talked about earlier, In this scenario, when that segment intersects the chord at a 90-degree angle, it gets bisected. So I'm just going to call that M for midpoint. So MB has to equal 15 units. And then what we really want to find is the length of OM, because the length of OM is the distance that the chord is from the center. So again, we can use the Pythagorean theorem here. Um, I remember that 17, 15, and 8 is a Pythagorean triple. If you don't, then you could just do the Pythagorean theorem out. But OM is going to have to equal 8 again, because 8, 15, 17 is a Pythagorean triple. And like I said, if you don't remember the Pythagorean triples, it's not a big deal. You can just apply the Pythagorean theorem, and you're going to be able to find the solution in the same fashion. All right, the last one. Example 7, we want to sketch circle R. Let's try that again. So circle R. Not as good as the first one. All right, so circle R. And in this case, this one has radius of length 5√3. And chord XY that is 5 units from center R. So I'm going to draw in this chord. And we're going to call the chord XY, because that's what we're told. And in this case, we actually know the distance. So we know this distance here is 5. So now what we need to do is we need to find the length of that chord. So I'm going to highlight that in yellow. So we want to find XY. All right, now in order to do that, what I'm going to do is I'm going to find the distance between X and this point here. I'm just going to call it M. And the way that I'm going to do that is to apply the Pythagorean theorem. So I'll just call that A. So A squared plus length of the leg is 5. So 5 squared equals 5√3 all squared. And now we can just find the value of A by evaluating this or solving this equation for A rather. So A squared plus 25 equals 5 squared is 25. The square root of 3 squared is 3, so that's going to equal 75. Going to subtract 25 from both sides of that equation. We're going to get A squared equals 50. And we'll take the square root of both sides to get A equals 50 has a perfect square factor of 25, so this will actually reduce down to 5√2. So we'll do that over here. The square root of 50 is the square root of 25 times the square root of 2. So that's where we're getting 5√2 from. So if A is equal to 5√2, then this segment, MY, is also equal to A as well. So we'll double 5√2. So XY is going to equal 10√2. All right, so what you're going to do right now is flip to the next page in your notes, and you're going to find that there's some class practice problems. So there are, I believe, 6 total. Let me double check that. There are 8 total. Okay, so there are the first 6, and then the next page you'll find the next 2. So you're going to complete these problems. I have posted the answers to these problems to Google Classroom, so you can check your answers there. If you have any questions or concerns, again, as always, you can email me or message me through Google Classroom. I hope this helped out, and we will see you soon.